So in this video, we're going to talk about just a whole bunch of derivatives, okay? So there's a big list here of about 24 derivatives that you need to memorize, all right? So it's a little overwhelming to look at all in one spot, but a lot of these we've already done before. The derivative of with respect to x of c times u, where u is the variable, u and v are variables, a, c, n are real numbers, where a is positive and n isn't equal to 0. The derivative of u is just u prime, okay? It's another way to say du dx is equal to u prime, all right? It's just a shorter way to write it. So it's just the constant rule right there. Now, product rule, first times the derivative of the second plus the second times the it's the first times the derivative of the second plus, the derivative of the second, or the first times, see, look, this is why I don't even like it to be in this form, right? Because the way we say it, we say the first times the derivative of the second plus the second times the derivative of the first, right? V u prime is the same as u prime v. All right, so sorry for that tongue twister. That's just a different way to write it. Nothing wrong with it. It's just I like my way better because it helps me with my quotient rule, because the quotient rule you end up flip-flopping those to be the way that I say it, where it's the first one and then the derivative of the second. You see how that's written there? So that's the reason I like to say it that way, so that it kind of helps me remember not only the product but the quotient rule. So, to each his own. Now, chain rule says I take the derivative of the outside, which is u prime, times the derivative of the inside, which is v prime, okay? So the outside is u prime of v, and the inside is v prime. The derivative of x is just 1. The derivative of e to the x is e to the x. The derivative of natural log of x, which we're going to prove here in just a second, is 1 over x, okay? Sine derivative goes to cosine. Secant derivative is secant tangent. Tangent is secant squared, and you see how these relate with the c's for the cosine, cosecant, and cotangent are all the negatives. Okay, so those all link up together. Cosine's derivative is negative sine. Cosecant is negative cosecant cotangent, kind of similar to secant is secant tangent. So cos, okay. Cotangent here is negative cosecant squared, kind of like tangent is secant squared. All right, goes back to the cofunctions. Same with your trig ones here. The c's produce negatives. Okay, so it's literally the exact same as 19, 21, and 23, but instead we have negative values tacked onto them. Okay, and so we just talked about those in a previous video. Now, sum and difference of a function's derivative. So the derivative of the sum is equal to the sum of the derivatives. That's what they're saying, plus or minus, plus or minus. So it could be the difference. Quotient rule, low d high minus high d low, all over low low. Okay, they've kind of got that written around a little backwards, but that's okay. If you were on a quiz or something and you write v u prime minus, so it's low d high minus high d low, all over low low, this is perfectly fine. Those two things are equal to each other. Okay? Derivative of a constant is 0. Power rule says I take the exponent, I bring it out to be a coefficient, and I subtract 1 from the exponent. Derivative a to the x is a to the x times the natural log of the base. The base is a. Now, this one's a little bit different, and we'll talk about this one more, but its derivative is actually, it picks up not a ln a factor, but a 1 over ln a, okay? And then it's natural log. So how does this relate here? The difference here, this base for number 11 is a base e, okay? And then this base is a base a, all right? So when it's a base e, you don't have to worry about that because that coefficient in front is a 1, because it is 1 over ln the base, but ln of e is 1, so that gives me 1 over 1. Okay, so you don't have to worry about that factor there, but it pops up here. And the reason it pops up, and we'll talk about it more in a second, but is the change of base rule. Log base a of x is log x over log a, but this is also the same as saying ln x over ln a. It doesn't matter the base that you use as long as you use the same base for the numerator and the denominator, and you can still get the same answer, okay? So when you take the derivative, this part pulls out that 1 over ln a constant, and then you already know what the derivative of ln x is. It's 1 over x, okay? So that's where that falls into play. All right. So let's go through this. So let's derive the derivative of ln x. Okay, so we know that the derivative of ln x is 1 over x. That's one of our rules. But let's show why that's true. Okay, so to do that, I start with e to the y. Now, e to the y, okay, say I have y equals the ln of x, right? If I e both sides, I get e to the y equals ln e to the ln x. Now, what do I know about e and ln? E and ln are inverses of each other, so they're going to cancel each other out, and so this is equal to x. So we just took y equals ln x and we transformed it into e to the y equals x. They're e and ln are inverses of each other. Okay? Now that I've transformed it, I'm going to use implicit differentiation to find dy dx. So I'm going to take the derivative with respect to x to both sides. The derivative of e to something is e to the something times the derivative of the something. The something is y, dy dx. Derivative of x is just 1. Now, how do I get dy dx by itself? I divide both sides by e to the y. It cancels on the left. And so what do I have? I have 1 over e to the y. But e to the y is defined to be ln x here. And so what did we say? E to the ln x reduces to what? X. And so this equals 1 over x. So we just proved that dy dx equals 1 over x. Okay, so that's how it's proved. Pretty cool. Let y equal a to the x. Now we're going to prove this. Okay, how do we prove it? Well, what do we know from our little table? The derivative of a to the x is a to the x ln a. We note that the derivative of e to the x is e to the x times the ln of e, but the ln of e is just 1, so that's just e to the x, so that means derivative of e to the x is e to the x, right? Based off of that definition where a is equal to e in this particular example. Let's do this though. Let's derive it. Okay, so what are we doing here? All right, so what have we done? So we've rewritten a to equal e to the ln of a. And why is this true? Because e and ln are the inverse of each other. This is just equal to a. And so what does that tell me? Say I take a now and I raise both sides to the x, right? If I do that, then I get a to the x equals e ln a to the x. So now I have a power to a power. I multiply, okay? So I have this here and this here, okay? So what do I do from this point? I'm going to implicitly take the derivative, or actually I'm just going to take the derivative, right? And so how do I take the derivative? Well, this is what I'm trying to prove the derivative of, right? That's what I'm trying to find the derivative of. So I'm going to take the derivative of this. So it's e to something. The derivative of e to something is e to the something times the derivative of the something. Well, the derivative of a constant times x is just that constant right there. Okay? So what do I know? Well, L and A match here. But what do I have? I have e to the ln a of x. Well, what do I know e to the ln a of x equals? It equals a to the x by definition. Therefore, the derivative of a to the x is a to the x ln a. Pretty cool. So now, instead of just in general a could be any positive number, right? Now, instead, I'm going to put a equal to 3, but I'm going to do something weird. I'm going to make the exponent sine of x. So it's a to something, right? Find the derivative. Well, to get the derivative, it's the base to the something, right? That stays the same. This part's always the same, right? But then the fact that the base changed and the exponent was a different x, right? So I have to treat it like a chain rule. So it's derivative of 3 to the something is 3 to the something, ln 3, because you got that factor from your base, but it's also times the derivative of the something there, okay? Chain rule. And so whenever I take the derivative of sine of x, I'm going to get the cosine of x, all right? So what does this end up being? It's cosine x ln 3 times 3 to the sine x. Let's take the derivative of tangent inverse, arctangent of 3x squared plus 1. Now, to do this, the way I think about it, I think of it, the derivative of arctangent of some stuff. This is a chain rule problem, okay? Well, what do we know arctangent is? The derivative of arctangent is 1 over 1 plus the square of the stuff. Well, what is my stuff here? My stuff here is 3x squared plus 1. So what do I put in here? I put the 3x squared plus 1. Okay? But chain rule says after I take the derivative of arctangent of the stuff and get that, I have to multiply by the derivative of the stuff. What is the stuff? It's still 3x squared plus 1. Now, to simplify this, okay, in the denominator, if I multiply this out, that's 1 plus, now 3x squared plus 1 times 3x squared plus 1. 3 and 3 make 9. X squared make x to the 4th. Then I have plus 3x squared plus 3x squared again, and then plus 1. But I have a plus 1 and a plus 1 makes the plus 2. 3 and 3 make 6x squared, and then I have the 9x to the 4th right there. Okay, so that's where that distributes out to get the denominator. Now the numerator is a little bit easier. I just take the derivative of 3 3x squared plus 1. So 3x squared, bring the 2 out front. 2 comes out front, 2 times 3 is 6, and then subtract 1, I just have x. And so that is my final answer. Okay. Now we come to the derivative of the log base 2 of x. The first thing I'm going to do is I'm going to convert this into a form that I know how to take a derivative of. And to do that, I need the change of base rule. Because I know that the derivative of ln x is 1 over x, I need to convert this log base 2 into a base e. How do I do that? Well, I use the change of base rule. So log base x over log ln of x comes from this top part, divided by ln of 2 comes from that bottom base right there. Okay? So that's known as the change of base rule. Okay? So change of base, and talk a little bit about this in college algebra. If you want to go watch a video in college algebra about logs and the change of base formula, you can. But that's the change of base formula, okay? So now that I know the change of base formula, technically I've got 1 over this ln2, and so that's like a constant, right? So 1 over ln2 could pull out, and then all I have to do is take the derivative of ln x, which, I know that's 1 over ln2 for the constant, but the derivative of ln x is 1 over x. So that's a 1 over x factor coming in right there. Okay? So your derivative right here, you're picking up that log or that ln2 whenever you have a log base 2. Okay? Derivative of secant. Now, derivative of secant is one that we know. Derivative of secant is secant tangent. I'm going to show you why this works, though. I'm going to define secant to be with the reciprocal 1 over cosine. So 1 over cosine means I use a quotient rule. Low, d high, so the derivative at top is 0, minus high, which is 1, d low, the derivative of cosine is negative sine, all over the square of what's below, cosine squared. So look, this reduces sine negative and negative make a positive, so that's sine in the numerator. In the denominator, there's 2 cosines, okay? So one of the cosines pairs with the sine x to make sine over cosine. The other cosine pairs with a 1, and I can simplify this to something that may look a little bit more familiar to you. So this would be secant 1 over cosine times tangent, sine over cosine. Okay, so the derivative of secant is secant tangent. Now, the inverse, I think I kind of roughly did this one in another video, but I want to show it all pretty in this one. So I want to take the derivative of inverse. First thing I do is I say y equals that inverse function, and then I want to solve for x, so I secant both sides. If I secant both sides, I get secant y equals x. Now the secant, secant and tangent secant and cosine are the reciprocals, right? Cosine is cot another hippie, so adjacent over hypotenuse, but the secant is the hypotenuse divided by the adjacent. So the hypotenuse is x and the adjacent is 1. So that's where we come up with this triangle here, because y is the angle, okay? Input an angle on trig. The output of a inverse trig is the angle, right? So what is this going to be? Well, I need to take Pythagorean theorem and apply that. A squared plus b squared equals c squared. So it'd be 1 squared plus a squared equals x squared. If I subtract 1 from both sides, I get x squared minus 1. And then I take the square root, and that's where this comes into play right here, Pythagorean theorem. Okay? So, if I take the derivative implicitly here at this point, then I have the derivative of secant of stuff is secant stuff, tangent stuff, times the derivative of the stuff, dy dx. Now the derivative of x is just 1. How do I get the stuff by itself? So dy dx by itself, I divide both sides by secant tangent. But lo and behold, secant is defined to be x over 1. So that's just x. Okay, tangent, though, is defined to be opposite over adjacent, so that's x square root x squared minus 1 for that second part over there. So the derivative here is right there. Derivative inverse secant is 1 over, should be the absolute value of x times the square root of x squared minus 1. Okay, guys, hopefully these videos were helpful for you. When you're taking derivatives, I guess I could do one more for funsies. I kind of feel like I want to do like one more chain rule problem. Maybe let's just pick this one. Okay, so I'm going to do sine inverse. So maybe I want to take the derivative of sine inverse of e to the x. Okay? So how do I take the derivative of this? Okay, this is equal to 1 over the square root of 1 minus the something squared times the derivative of the something. But what is the derivative of the something? Well, it's e to the x, so I'm going to put in here an e to the x and an e to the x. Okay? And so what is this going to be? This is going to be 1 over the square root of 1 minus, now power to a power, I multiply e to the 2x. Okay, multiplied by, well, what's the derivative of e to the x? That's just e to the x. So this simplifies to e to the x over the square root of 1 minus e to the 2x. Okay, so that's your derivative right there. All right, guys, that ought to do it.